And I do know of motors that have gone through like multiple sets of bearings and everything looked fine. And what it was the crankshaft was polished in the direction of rotation. You know, the belt was traveling in the direction of rotation instead of against it. So you want the belt to lay down any ferrites. And like I said, on a forged crank, that's not really an issue, but it's a good idea just to be in the practice. And like I said, this was done by one of the best guys in the business, so you know, it was clearly done that way. Okay, we're setting up our dial bore gauge now and our micrometer, and we're going to go through and we're going to check the main bearing clearances. Okay, and once again now we shall go ahead and run the dial bore gauge in here. And again, now I'm only going to concern myself with side to side because I know this is going to be out of round because bearings are not round, they're elliptical. So I'm just going for side to side. If this were a V8, like I said, I'd be going for vertical. And we'll just check this right here. See. Wow. Shell. Something turn it that way. Boom. All right, looking good. All this information, of course, will be recorded in the on the build sheet, all the dimensions everywhere. I've already previously mic'd up the camshaft and checked the cam bearing clearance because, like I said, we lapped the case, which obviously makes the holes a little smaller, and we had the cam bearings coated, so that again closes things up a little bit. But Corvairs are kind of notorious for having loose cam bearings because, you know, it's not the best system in the world. So we wound up with 1.5 thousandths clearance, which is plenty on the camshaft. So we're ready now to pull this back apart, lube things up, and throw in the crankshaft and the camshaft, and then degree in the cam, and then that will complete complete the bottom end. Okay, I'm getting ready to put the crankshaft and camshaft in now. Personally, I like to use Lucas semi-synthetic bearing lubricant. There's plenty of decent ones out there, Torco, all kinds of different stuff. One thing for when you're doing this, I know there are some guys that like to really glob this on, and you know, it's running and dripping and all over the place. All it does is make you look like a backyard hack. You have 2.5 thousandths bearing clearance or thereabouts. Any layer you put on that, well, if you put on a layer 2.5 thousandths, that's more than you need because you can have 2.5 on the other side. Obviously, half you're going to push out. You can't put on just the minimum. You know, you're going to push a little bit out. But you should just put on a decent layer, a few thousandths thick. A little bit's going to ooze out. When you're done with the engine sitting on a stand or whatever, you know, you might get a nickel or dime size drip under the engine after a couple of days. If you have this crap, you know, running and oozing all over the place, it just makes you look like a hack, and it's not doing any good for the, you know, anything any better. So all we do is we just put a little bit on, just like that. Then I just rub it with my finger here a little bit, and that's plenty. Okay, again, here we go, just a little dab like that. Now we just move it with the finger, and that's plenty. And here on the thrust bearing, we want to make sure that we get the thrust surfaces. I put a little bit on my finger here, and we get that. Now sometimes when I'm building a motor on the thrust surface, I'll use some moly lube like you use on the camshaft. This motor we can't because these bearings are coated, and that moly lube is not good for the coating. So we can't use that, and we're not using it on the cam either. The cam is also coated, so there will be, you know, no moly lube used in this motor whatsoever. I've had people say, you know, well, gee, the motor's only going to be lubricated by oil. Isn't this kind of gilding the lily? You know, putting on all this super lube and all this other crap here. By the time this thing gets started, it's going to have been turned over so many times it's ridiculous. So if nothing else, you know, you should use this just because you're going to have to turn the motor over multiple times to adjust the valves. We're going to degree in the camshaft. If we were just using regular engine oil, you know, there would be metal-to-metal contact before we were done. Okay, now it's time to lift our camshaft into place, or rather crankshaft into place. And you'll notice also that the crankshaft has also been painted with that same GE Glyptal paint. Again, just to help it throw oil off. Now for the camshaft. By the way, the Corvair camshaft has to be about the most difficult camshaft in the world to install. The camshaft, the timing marks are just about impossible to see. Just looks like a little nick. If you didn't know what to look for, you'd swear somebody dropped the crank and nicked it. This one here, the timing marks are a little bit off. You'll notice I put a line through here so I can see. Here's my timing mark. What I'm going to do is I'm going to line this up this way, and that should be right. Now, I'm using the Ray Sedman's adjustable cam gear, so you can see all these slots here, so you're able to, instead of having to pull the case back apart and using offset keys to degree in the camshaft, you're able to just loosen up these screws. I'll put in 2 longer socket head cap screws so I can grab them and twist the camshaft to turn it to where I want. This is a terrific gear. Only problem is it is bigger on the backside than the factory gear is. Requires you to do a little bit of clearance here on the casting, and it does make it a little bit more difficult to initially install the cam, but it is well worth any effort. Okay, and that looks like the timing. I got the timing marks lined up. I can see this real well. It's impossible to see from this way. You got to look down here. I slide the cam all the way this way now, and I'm going to rotate it on the gear, and it's going to just barely clear this casting boss, and now, yeah, I can get it to drop in. And now it's in, and hopefully still lined up perfectly. Okay, now we do the same thing here. Give this some bearing lube. And also, before I did this, I washed my hands so my hands would be clean, so I wouldn't be getting dirt from my hands onto the bearings. Okay, so now we'll just put the case halves together. And again, this can be a little tricky because of that cam gear. So we'll kind of lower it down into there, and then we got the thrust bearing on this side, and there she goes. Alright, something I should tell you about these case studs, I have numbered each hole and numbered each case stud. So each stud goes in from the same direction, facing the same way, in the same hole each time. This is from when it was, first line honed till now. So, if just consistency is important. If there's anything that's a little off or something, it's a little off the same way all the time, and you can compensate for it. ARP loop there, just the tiniest little bit on the center section here, and that goes number 1. We have these all laid out in theory in order. Number 2, a little more. snug these up just a little bit. Now we'll give a quick check on the end play. Okay, I'm getting 4 thousandths end play. Yeah, 4 thousandths. I'll live with that. Okay, now we're going to degree the cam in. We've got some very Corvair specific tooling for doing this. First thing we have to do is get on a cylinder. I'm putting in cylinder number 2 because cylinders 1 and 2 both hit top dead center at the same time. And by doing number 2, that keeps the cylinder out of the way of the dial indicator on the lifters on number 1. There we are. There you go, don't even torque them, just snug them, it's just fine. There we go, make sure that's all pulled down nice and tight. Now we can stick our indicator on here. Now for cylinder number 1, we have this, and before we put that in,